Welcome to U5L1 trigonometric ratios. So there are 6 of these trigonometric, or trig for short, ratios. They define a relationship between two sides of a right triangle and an angle in that right triangle, okay? One of the acute angles in specific. In geometry, we're only going to learn about 3 ratios. They're the 3 basic ratios. They're called sine, cosine, and tangent. And in order to understand these, you have to understand how we label the sides, or how we identify the sides in reference to a specific angle. So let's say our reference angle is angle A, okay? If our reference angle is angle A, then we can label our hypotenuse, our opposite side, and our adjacent side in reference to angle A, okay? I shorten that to our HOA, okay? So the hypotenuse is always across from your right angle, so our hypotenuse is side AC. The opposite side from angle A is going to be the side across from angle A. So the opposite side is going to be CB. It's this side across from angle A. So that's the opposite side. And the adjacent side is going to be the side that is next to angle A, but not the hypotenuse. So the adjacent side here is actually going to be this side AB. Once you have those labeled in reference to whatever the reference angle is, then you can go ahead and find your 3 trig ratios, which again are sine, cosine, and tangent. So the sine of an angle is shortened to SIN, but we still say sine. So the sine of A is our reference angle, so let's actually write that down. Okay, that is our reference angle. Okay, so the sine of A is equal to the ratio of the leg opposite of A over the hypotenuse. So O over H. The cosine of angle A, shortened to COS, okay, so the cosine of angle A, shortened to COS, is the leg adjacent to A over the hypotenuse, or A over H. And then the tangent, shortened to TAN, okay, the tangent of angle A is equal to the leg opposite of A over the leg adjacent to A, which is O over A. So there is this little shorthand acronym that some people like, SOHCAHTOA, and that is to help you remember what each ratio is defined as. So the sine is opposite over hypotenuse. That's the SO part. Cosine is adjacent over hypotenuse. And TOA, TOA, tangent is opposite over adjacent. So just to memorize these, okay, with the first letter of each ratio, that's what SOHCAHTOA gives us, okay? All right, so go ahead, look at example 1, using angle C as the reference angle. What is the hypotenuse, side opposite C, and side adjacent to C? So once you know what your reference angle is, and it'll give it to you in numerous different ways, but once you know what that reference angle is, circle it. So angle C is our reference angle, so circle angle C. Now let's label HOA. So hypotenuse first, across from the right angle, that's the hypotenuse. So the hypotenuse is equal to 50. The side opposite of C, so the one that doesn't touch C at all, it's across, is going to be 40. So that's going to be O. So the opposite side is 40. And then the adjacent side, whatever's left, the one that's next to C but not the hypotenuse, is going to be 30. Okay, and that's how you identify those angles. So always remember to circle your reference angle. Okay, identify your hypotenuse across from your right angle. Identify the opposite side that is across from your reference angle. And adjacent is the one next to it that's not the hypotenuse. Perfect. Okay, let's take a look at example 2. Find sine x, cosine x, and tangent x. Notice that I did not shorthand them when I said them, right? I still said sine of x, cosine of x, tangent of x. Perfect. All right, so my reference angle here is x. So circle x. Now label hypotenuse across from the right angle. So this is 10. Your side opposite of x, which is the one across from it, is going to be 6. So the side opposite of x is 6. And then the adjacent side is what's left, which is the one next to x, which is 8. Now you can write them down if you want to separately, or you can just put them into your ratios. It's up to you. Remember, our ratios are defined using specific sides of our triangle in reference to angle x. So the sine, S-I-N, of x, so the sine is opposite over hypotenuse. So for our numbers, opposite was 6 over hypotenuse, which was 10. Simplify that fraction, and you will get 3/5. Also write it as a decimal. You'll divide numerator by denominator, so either 6 divided by 10 or 3 divided by 5, and you will get 0.6. So we can write it as a fraction or as a decimal. Okay, so there's 2 ways to write that answer. All All right, let's take a look at cosine of x, again shortened to COS. So cosine of x is equal to, and you can take a look over here, cosine is equal to a over h, okay? So cosine is a over h, and that's going to be 8 over 10. Simplify, you get 4/5. Divide 4 divided by 5, and you get 0.8. Tangent, last but not least, that's the TOA part of our little acronym. So tangent is O over A. Opposite was 6. Adjacent was 8. Simplify those, and we get 3 over 4, which is equal to 0.75 as a decimal. And there we go for number 2. Now for number 3, I'm going to need you to change these values if you have the one that is incorrect, okay, the paper that is incorrect. We're going to find the sine, cosine, and tangent of angle C, So our reference angle is angle C. But I need you to change the numbers. So I need you to change 18 to 15. I need you to change 24 to 36. And I need you to change the 30 to 39, please. Perfect. Okay, so now what we're going to do is we're going to find sine, cosine, and tangent of angle C. So sine is SIN with your reference angle of C in parentheses. And remember, so, ca, toa. So, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And toa, tangent is opposite over adjacent. So for sine of C, let's go ahead and label our sides. So hypotenuse is across from the right angle. That's going to be 39. Opposite of C is going to be that 15. And then adjacent is going to be the 36. All right, so sine is opposite over hypotenuse. So that's going to be 15 over 39. We're going to simplify. If you're using the calculator, remember it's alpha and the one next to alpha. So that's going to be 5 over 13. They have a 3 in common. And if we divide 5 divided by 13, okay, I actually want to show you guys what happens here. A lot of times when you go to find the decimal answer, you're not going to get a nice pretty decimal like I did earlier, okay? So when you go to divide numerator by denominator, you're actually going to get something kind of ugly like this. So usually it'll tell you where to round to. If it doesn't, then it doesn't really matter. You can round to the tenths place, where the 3 is, or the hundredths, right, or the thousandths. I'm going to go ahead and round to the hundredths just for the sake of this. So it's 0.38. If it rounds up to a 9, the only time that will happen is if the number after it is 5 or more. Since this is a 4, okay, we don't care about anything else. Since the number directly after the 8 is a 4, we will round it to 0.38. Okay, it'll round down. So this is going to be 0.38. And remember, that was 0.384. Okay, and so it rounds down. Okay, let's look at cosine of C. Cosine C is equal to adjacent over hypotenuse. So that's going to be 36 over 39. We're going to simplify that. So 36 over 39, they have a 3 in common again. So that's 12 over 13. If I divide 12 divided by 13, I get 0.923, which again rounds down because the number after it is less than 5. So it's 0.92. Okay. And then last but not least, I can ignore those now. So last but not least, we have tangent of C. Tangent of C, which is opposite over adjacent. And that's going to be opposite of 15 over adjacent of 36. Again, they have a 3 in common. If I take out that factor of 3, I end up getting 5/12. And if I divide 5 divided by 12, I get 0.41. Ooh, so this is a good example. So I end up getting 0.416. If I want to round the 1 and the next number is 5 or more, it rounds up. Okay, so that 6 goes away no matter what, but you're going to get 0.42 here. So be very careful when you're rounding. In this case, we were rounding to the nearest tenths. Okay, so there are our answers. All of them as fractions, simplified fractions, and rounded to the nearest tenth. Oh, hundredths. Excuse me, not tenths, hundredths. Okay, I'm just going to put here. Rounded to the nearest hundredths, which is 2 after the decimal. Okay, so you may want to make a little note of that just because we're going to use this a lot in this unit when you're rounding. So I'll just write down some numbers. So this is tenths. This is hundredths. And this is thousandths. So if it doesn't specifically say how many places after the decimal, if it says tenths, hundredths, thousandths, then now you know where you're rounding to. So you look at the number after that number, and then that's how you determine whether it rounds up or down. So that's just a little side note for you, just to remind you of what those place values are. All right, thanks for watching. Have a great day.